and well, actually, it began with what seems a bit stereotypical for most people. It's just famous one. I mean, who can avoid that one? So it really started for me with that in science, right? And as I progressed, I realized that I couldn't do that science properly without a good foundation in mathematics. And as I was delving deep into the mathematics, I realized that mathematics is also pure and beautiful on its own. I mean, aside from all the equations, you get things like Sierpinski's triangle. It's a fractal.
Yeah, put it on YouTube.
Yeah.
Like a million. I'm recording right now.
And then it keeps going, and then it keeps going.
Just fractal?
And then it's the Koch curve. Who would like to come up and draw the Koch curve for us?
Donna.
What? The what? The what?
I was testing you because you all said that you knew what a fractal was.
I know.
Iteration. It's an iteration, and this one's a really bad one.
Better than what I can draw.
Why is the camera being...
So this just proves that math isn't all just numbers. You get beautiful things like these in it.
Can you write my ED?
That would be plagiarized.
And then,
Hey,
at first I just...
no man.
At first, my dad just really, wanted me to just get good at arithmetic, but then I knew I needed something more. I needed more than plain arithmetic. So, I read the Murderous Maths books on algebra. And at the age of, I think it was 9 or 10, and then with algebra, actually, my first reading I didn't get it, but in the second or third reading, I started, having fun with stuff. Of course, there's the linear equations, then you get to plot, and then quadratics, and then simultaneous ones. Oh, they're like drugs, except healthy to me.
Good for you, right?
I'm not saying that you should take drugs. No, that's a very bad idea. And as I dove deep into both these topics, physics and mathematics, I, really just realized how misinformed the public was. You get E equals MC squared, but you don't get the actual form. E squared equals MC squared to the fourth. Oh, good, someone knows it.
I know it.
No, this, oh yeah.
And then P
to the
squared,
fourth,
P
and then, right, when you
That's
explain
P
it, sorry.
squared.
Yes, PC squared. But then the thing is, when this doesn't look as nice as E equals MC squared, but when you represent it with mathematics like a right triangle, then it's so easy to understand. If we just call,
Pythagoras theorem.
let's see, this MC squared, and then this is PC squared. And this is just E squared, and then all you need really is Pythagorean theorem. Next. All you need is the Pythagorean theorem to understand what this really means. If you kind of like squeeze it so there's no mass, so the mass becomes 0 and that just cancels to 0, then your energy would be equivalent to, the momentum times your times the speed of light squared. So you really realize that math isn't just all this. When you take it really and put it into these forms, then things become easy to understand. You're not just stuck staring at that equation, not having any idea why it's important. You just know that it's important. And then you look at this, and then you get it. It's quite simple when you put it in.
Justin, what do you want to do when you grow up?
What do I want to become a physicist and mathematician.
You're already...
You're more than halfway there.
And then you get even better stuff.
What does your dad do?
My dad, well, right now he works in HP, but once he took engineering.
He's an engineer?
He took engineering. He's not an engineer anymore. Well, I mean, you get beautiful stuff as well in physics, but you can't do them without the math. If I just drew this, and then I just drew, I don't know, metric tensor, say.
Sorry, they didn't hear you. What did you say? You drew what?
This is just the metric tensor, yeah. You can just get it from, like, if I remember correctly, expansion of Pythagorean theorem in 3 dimensions. G mu nu becomes the correction once you add time, and because the quantum delta isn't zero anymore, and it doesn't cancel. But this is what's called a covariant derivative. And a covariant derivative is just like a normal derivative, or in this case, just a normal partial derivative. You have to be careful there. But then you have this extra term called the Christoffel symbol. And then at first it just seems like a, no correction. Yeah, it's just a random correction. But then from this you can get all the other stuff in Einstein's field equations. So math really is the language. Math really is the language you need to know. Because if you don't know the math, then you don't know all this stuff. You can't get all these extra things like there are these expansions in mathematics that once you do them, you can figure it all out. Famous expansions. Like there are these expansions of factors, and then you get all these small terms once you don't get to relativistic speeds, and then it becomes even more beautiful.
You guys should go
Guys. We're staring at our future dictator right now.
Would you like to show them the video that you want? A video, one of your favorite videos from.
Okay, then. Anything?
Yep, from math.
Okay, for math. Good.